Okay, so we're going to start talking about logarithmic functions in this section. And I think you'll like 4.3. It's pretty fun. Okay, so let's look at some things. Let's say we have 5 to the power of 0. Well, we know that's 1. Say we have 5 to the power of 1. We know that's 5. Say we have 5 to the power of 2. We know that's 25. But now let's say we want to know 5 to some power. We want it to equal 10 or, 11, something like that, some other number, right? We know that that exponent, it could be a rational exponent. It could be a fraction. It could be a decimal. We don't know what that number is, though. We don't know what 5 to some power equals 10. We don't know what that power would be. We know it's going to be between 1 and 2, right? So we could guess. We could say, well, what's 5 to the 1.5 power? And you could do that on your calculator. Let's do that on our calculator. Let me turn on my calculator. 5 to the power of 1.5. Well, I get 11, it's approximately 11.18. So it's kind of close to 10, not too bad of a guess. Needs to be a little lower, so I could guess, well, maybe what's 5 to the 1.4? And I could put that in my calculator. 5 to the power of 1.4. And I get 9.52. Okay, so I know it's between 1.4 and 1.5. But do you see, this would take like a long time to figure this out. And so we don't have to do that. Someone a long time ago invented logarithms so that we have a way to write these things out. Okay? So here's the relationship. It has to do with exponential functions, and a logarithmic function is actually the inverse of an exponential function. All right, so let's look at what we know about exponential functions. We know exponential functions can look like this. We know that b has to be, has to be greater than 0, and it can't be 1. And what else do we know? We know the domain of that function goes from negative infinity to infinity. And we know the range, is from 0 to infinity, right? So those are some things we know about an exponential function. Now, I kind of wish I didn't put the a there. So I'm going to rewrite this in a little bit simpler form. Y equals b to the x. Okay? We're going to use that then to write a logarithmic equation. So right now, this is an exponential equation, or sometimes they'll say exponential form, okay? It's very similar to the function that I wrote. Okay, so now I'm going to write the logarithmic form. It's going to be log. So you write the letters L-O-G. They're not italicized. It's just L-O-G. This is a function, okay? We don't have a special symbol for it, like square root function. We have a special little sign for that. But for logarithm, we just write L-O-G. It has to have a particular base, and that is a subscript, okay? That base comes from the base over here. So that little b, we say the log base b, and then we have to take it of something. There has to be what we call an argument. It's called an argument. You may have seen that with other functions. Well, this says argument. You take a function of something. So a logarithm's a function. You're taking it of something. In this case, it would be y. And that relates to the y over here. And then the whole thing is going to equal the exponent, x. Okay? Now that's the relationship between the logarithm function and the exponential function. Okay? The two forms Okay. The book, they wrote it just a little bit different, so I'm going to write it their way just so you can see it. There's nothing wrong with what we have here, but they write log base b of x equals y, and there's a reason. Later on we're going to want to graph it, not in this section, but, and then they're going to say the exponential form is the base b, the exponent's y, and it equals x. Okay? This is the relationship. So I'm going to put a double arrow here to say you can go from one equation to the other equation. And it doesn't matter if you're going, you can go from exponential to logarithm, or you can go from logarithm to exponential. It all depends on what you're doing and what form is going to help you. Okay? So this is the log form, logarithmic form. And this is the exponential form. They're both equations. They're just written in different forms. Is one better than the other? Well, it depends on what you're doing. So sometimes we need it in exponential form. Sometimes we need it in logarithm form. Okay? Let's see. Is there anything else? Oh, I want to talk about the reading of it. So it's log base b. We say log base b of, x equals y. That's how you would read that. Okay. We're going to practice in the next couple videos going between the two forms, because that's half the battle with logarithms. So we use logarithms to help us because we don't know how to do things like this. We don't have algebraic ways of dealing with that. But logarithms give us that tool. Okay, so it's a new function, and the relationship is that they're inverses of each other. The exponential form and the logarithm form are inverses of each other. Okay, going back to that then, we can say a little bit more about the logarithm form. Okay, like, we know b has to be greater than 0 still, and it can't be 1. And what do we know also? We know that x has to be greater than 0. Now, why is that? Well, look back in the exponential form. When you have a base, the base is positive, you're going to raise it to some power. You're never going to get a negative number. Think back to your domain and range. There was never a negative output, right? So on the logarithm side then, the argument has to be greater than 0. It has to be positive. Okay, now that's going to come up, so you're going to have to remember that. Anything else? One more thing, domain and range. Domain is going to be the range from the inverse, right? And then the range is going to be the domain. So they switch places. Okay, I think that's all I want to say about logarithms in this video.